Hi everyone, in this video I want to talk about graphing an ellipse. Here is the single problem that we'll do, and to make sure we don't take ourselves too seriously, let's think about the fun question. What were you doing during the single minute when you were happiest in the last month? Think about that single minute. What was the happiest, from this past month? So on the ACT math section, occasionally you will see a question related to conic sections, that is, circles, ellipses, parabolas, and hyperbolas. It's rare to find one of these, but occasionally you could be given a graph of an ellipse and asked to find something like what we have here in the directions, potentially the center, co-vertices, vertices. I've even seen the focus points on there before. I was surprised once seen a major axis and minor axis mentioned. But always it seems like you're given the graph and asked to find something from the given equation or match an equation with the graph potentially. So this one problem really covers our bases for any of those possibilities. What I will do is start with the equation and go from there. So I can tell that this particular ellipse is going to be a horizontal ellipse, and I'll show you why. The equation for an ellipse is always x minus h squared and then y minus k squared, just like a circle. You can see a video I made on circles and writing equations and graphing. But ellipses are always equal to 1, and they always have fractions involved. So the a number we'll call always the larger, and b always the smaller. Because here this a is greater than b as you read it left to right, this is going to be horizontal, a horizontal ellipse. So this I can tell because it's 5 squared and 4 squared. Similarly, the 5 is greater than the 4, so it's going to be horizontal. And that the opposite of that would be if you had x minus h squared over b squared, y minus k squared over a squared. It's like the large and smaller flipped. So this is when b will always be less than a, but I kind of use that as my little note to write, okay, that's vertical. So that would be like if the 16 was here and the 25 was here. Now, it asks for a whole bunch of information. So let's just write it all out and go through it. So center, in this situation, it's the HK, just like it is for circles. So it's going to be 1, 1, because notice the minus in the formula, so that's positive for both of them. Then next, it's probably best to just graph it and then state all of those pieces. So, okay, we have a center at 1, 1, and then the major axis is going to be the horizontal axis. In this case, it's the longer of the two. So major is larger and then smaller axis. Okay, so I'm going to go, this 5 is tied to the x and the 4 is tied to the y. That means on the x axis of this ellipse, I'm going to go 5 over and 1, 2, 3, 4, 5 over this way. Because the 4 is stuck with the y, I'm going to go up 4, down, and up. So I'm going to try to connect it in a rounded formation. And there we have the ellipse with 4 up, 4 down, 5 left, 5 right, the vertices will always be tied to the major axis. So we had, 5 over, 5 over. So that major axis is going to be 10. In this case, minor is 8. And then the vertices are on that major axis, so they're like here and here. So I'll put like vert, covert, vert, covert. Vertices are at 6, 1, and -4. Covertices are at 1, 5, and 1, -3. The only thing I haven't mentioned yet is the focus points, foci. Sometimes people say foci. The way in which you figure out those, and I have seen focus points referenced on ACT questions towards the end of a test, like the hard questions, the 50s. 50 through 60 is always the hard one. To find foci, it's actually pretty easy as long as you remember that you have to use something similar to the Pythagorean theorem, but it's actually kind of a wannabe Pythagorean theorem. It's a squared minus b squared. So thankfully, this a squared and b squared are the same a squared and b squared from the problem. So you would actually just plug in 25 minus the 16. You get c squared, 9 equals c squared, c equals 3. So this 3, the 3 units that it's referencing would be from the center on that major axis. So 1, 2, 3 out, 1, 2, 3 out. There's a little focus point and there's another one. So, and I should be drawing probably a line right here so you can see them all tied together. Focus points are really interesting. You can actually do a simulation where you draw a perfect ellipse using the focus points and like a connection to the entire perimeter of the ellipse. You can use focus points with all of the other conic sections as well, but I tried to keep it really simple for this shape where it's just a similar formula to the Pythagorean theorem. You use that to find the number of units from the center on the major axis, so the a squared axis. So that is that big problem in a nutshell. We did complete it. We've done it all. And now I have a practice problem in case you would like to try it. So we have the problem here, and it asks you for all the same information and also to sketch the graph. So why don't you try it? And I will pause the video so you can see the answer. Okay, so the solutions are all here. You can see that this is a vertical ellipse, and the center, you can tell from the equation, but the nice thing is that all of these are integer numbers. Sometimes you get square roots in these, but I chose this problem carefully so that you do get nice integers, which I think you can expect on a standardized test as well. So I hope this video helped you. Here's a quote for some inspiration. It doesn't matter how slowly you go, so long as you do not stop. Thank you, Confucius. That's a really good one. That's our growth mindset where we don't have to be perfect, but if we continue to move through whatever we're trying to work on, it's probably the most important part. So feel free to tell me your answer to your fun question, your happiest minute of this last month. And if you would like to keep up with new videos, feel free to subscribe. I hope you have a wonderful day.